Right, okay, we're back. Maillard reactions mentioned greatly improve the organoleptic properties of food by enhancing flavour and colour. These complex reactions also produce some products which may have adverse effects on human health, however. In the case of one key molecule, acrylamide, the problem has only come to light in the last decade or so. Reducing acrylamide in affected foods is a key food industry focus at the moment. Okay, I mentioned this a couple of slides back. Hydroxymethylfurfural, HFF, is a Maillard reaction product derived from the dehydration of certain sugars. It's generally absent in fresh honey, but is formed during heating, conditioning and storage. The levels here quoted are set in Codex Alimentis and are designed to ensure both quality and safety. Okay, so we'll click on so it has some potential health benefits. It may be an antioxidant, it may be anti-inflammatory, for example. Evidence isn't particularly strong on this, so we say there is some evidence, not that it is. On the other hand, it has some potential negative effects as linked there. Again, evidence is not strong on these. If you see the paper that's linked by clicking on the image, it goes in quite a lot more detail. I'll leave you to find definitions of anything you don't already know. And just to reiterate again, in both areas these conclusions are tentative. I mentioned Codex Alimentis, so just a quick reference to what it is, or perhaps a reminder. Codex Alimentis Commission develops and adopts food standards that serve as a reference for the international food trade, and also feed into legislation at European and national level. Okay, this is the molecule of most current interest in terms of the potential adverse effects of Maillard reaction products. Acrylamide forms naturally in food cooked at high temperatures and forms in relatively high amounts, milligram amounts, which is high amounts. If you could extract it from a bag of chips, for example, you would be able to see it, so it's quite a lot compared to the micronutrients we often talk about in food and microcontaminants. It is of concern because it's a potential carcinogen in humans. And as mentioned, there's a lot of interest in reducing acrylamide levels in products like crisps. One of our former students did his placement year at KP Snacks at Billingham, which is the largest crisp factory in Europe, looking at just this issue. Generally speaking, the more Maillard reactions have taken place, the greater the concentration of acrylamide is in food. So some links there to the Food Safety Agency for more information, and they discuss why we shouldn't store potatoes in the fridge. We'll discuss that more later in the lecture. Yeah, so we've only known about this a little while. We've only known that some foods contain relatively high amounts of acrylamide for about 20 years, and its discovery had nothing to do with food. During 1997, a railway tunnel was being constructed through Hallandsås, a bedrock ridge in the Bahi Peninsula in southern Sweden, and I'm sure I pronounced them completely wrong. Cows started to show strange symptoms, staggering around, some collapsing and dying. This prompted an investigation that showed they'd been drinking contaminated stream water. The contamination was acrylamide, which was assumed to have originated from the use of polyacrylamide as a crack sealant in the tunnel, as illustrated by these small versions of polyacrylamide sealants. Fish in a fish farm downstream of the tunnel also died, so tests were immediately carried out on construction workers to see if they had unsafe levels of acrylamide. It turned out that they had. When Margaret Törnqvist of the University in Stockholm examined a control group who had no known exposure to industrial acrylamide, she found they had surprisingly high amounts of acrylamide in their blood. At first she thought that burgers might be the cause, but then she discovered high levels of acrylamide in a range of potato products like fried potatoes, chips, french fries if you will, and crisps. And that started the ball rolling. Yeah, further research confirmed previous results. If you click on the link here, the Chemistry World link, you'll find a range of articles about acrylamide in food, but we know from 2007 it confirmed the proposed link between dietary intake and acrylamide and cancer. We've got to be careful about saying that. We never say, for example, acrylamide causes cancer. We say it may be associated with a higher incidence of cancer in the population. Still under discussion how serious the risk is, but the food industry is taking steps to mitigate it. Okay, this is how acrylamide is synthesized by Maillard reaction. It requires the presence of the amino acid asparagine. It's pretty ubiquitous in food and has a high cooking temperature. Yeah, it needs high cooking temperature as well. This forms the usual Schiff-based intermediate, which decomposes to produce a range of things, including melanoids and the molecule of concern, acrylamide. As mentioned, this is nothing new. The oldest possible evidence of cooking comes from some 790,000 years ago from charred wood from Israel. The oldest definitive cooking remains we know of are from 400,000 years ago at a site near Beijing. So acrylamide's been in the human diet for a very long time indeed. Okay, here's a data visualization I did. But you have a click on it. I'll probably look at this in the tutorial as well. You can play with these sort of mounts in various foods. So I don't want to do videos and this sort of links in external videos and this sort of links in the videos because it makes things quite complicated and you can do it yourself. Okay, here's the process. Cold sweetening. Why you shouldn't keep your potatoes in the fridge. Storing potatoes in the fridge is a bad idea. It promotes a process called cold sweetening. This is the conversion by the enzyme invertase of the non-reducing sugar sucrose, remember it's non-reducing, into reducing sugars. So we take a non-reducing sugar and that'll produce a reducing sugar, which obviously then can promote Maillard reactions, including the production of acrylamide. Here's the invertase action. So there's sucrose. In the presence of the enzyme invertase, it gets hydrolyzed, producing glucose and fructose, both of which can undergo Maillard reactions and will react with asparagine to produce acrylamide. Okay, here's a study which is in the notes. It's in the folder for the notes for the lecture. This study analysed the reducing sugar content in 48 Andean potato hybrids. A comparison was done between freshly harvested samples and those stored at 4 degrees for 2 months. See the paper for details of the analysis. It's pretty clear from here. The darker bars are those that have been cold stored. It's pretty clear that cold storage promoted the production of reducing sugars, which would increase the production of Maillard reaction products, including potentially acrylamide. And there's some pictures, a visual representation of the results. The potatoes were sliced, dried with paper towels, fried at 180 for 2 minutes, or until bubbles were not observed in the oil. And then the chip colour was visually determined using colour cards, and there's also a chemical analysis done. How are we doing? Yeah, okay, we'll go on a little bit, then we'll pause again. So, reducing acrylamide in food. All food business operators, FBOs, are required to put in place simple, practical steps to manage acrylamide within their food safety management systems. This ensures acrylamide levels are as low as reasonably achievable in their food. Note that it is not practical usually to eradicate acrylamide from food. The focus here is on controlling levels in a reasonably practicable way. And there are a list of products. I've summarised that a little bit. If you click on the FSA image, I'll take you through a link which will give you full details. Okay, they're expected to be aware of acrylamide as a food safety hazard and understand in general terms how it's formed in the food they produce. Now, it may be a small company that doesn't have a food chemist on board, but there's plenty of resources which will help people understand that. You might be involved in developing resources or helping companies out in the future. They need to take the necessary steps to mitigate acrylamide formation in the food they produce by following relevant measures, which we've talked about and we'll talk about in a little while. Undertaking sampling analysis where appropriate to monitor levels of acrylamide. This would normally be done by an outside company. Many companies won't have the ability to do this, and also it then allows for an independent assessment and keep appropriate records of any mitigation measures taken, along with sampling plans and results of any testing. The measures are meant to be proportionate to the nature and size of the business to ensure that small and micro businesses are not burdened. But a micro business would be expected, for example, not to cook crisps intensively to produce more Maillard reaction products than is appropriate. Okay, I will pause there and we'll continue in a second.